Hello, everyone. Welcome to the Substance live stream. My name is Wes, and I will be your host today. On today's show, we have with us Daniel, co-owner and 3D artist at One Block City. Daniel worked with us to produce some amazing artwork for our latest Substance Alchemist release, and he will showcase his work for us today. And speaking of Alchemist, I am thrilled to have with me Baptiste, the Alchemist Product Manager, and Rosalie, our senior software engineer with research and labs. Rosalie is the brains behind our new AI-powered image to material filter. Welcome, everyone. It's awesome to have you here on our show today. Glad to have you guys. Hello.
Hello, Wes.
Hello.
So we recently updated Substance Alchemist to 2020.2. I'm going to start off today with just a quick demo. So I'm going to share my screen and run through a few of these updates. Okay, so I have my screen share up and running. So with our latest Substance Alchemist release, we added a new image to material filter that is powered by a neural network. And so with this goal is to provide, excuse me, had that messed up for a second. The goal is to provide amazing results without having to fiddle around with dozens of parameters. Later in the show, Rosalie is going to go over this entire process and give us an in-depth look at how this new AI-powered filter works. We also added some new options for being able to work with mass painting in the 2D view. You can now easily paint mass for your materials. We also added new custom mass blend modes. We improved the option to drag and drop textures so you can get content from anywhere or any library within Substance Alchemist. We added new tools, which include a new blend mode with a per channel blend, text input parameter support, new meshes like shoes and t-shirts, hybrid filter composition. We added new shortcuts for working with Atlas decals, as well as new perspective correction tools. There's also other new features as well. So be sure to check out our Substance magazine, where you can read more about the entire release, as well as detail some information on the content that Daniel's going to be sharing with us here today. Now, as I said, we're just going to run through just a really quick demo. So what I'm going to do is just come over here and fire up Substance Alchemist. And I am just going to give you guys just a really quick demonstration of how the new image to material AI powered works. So what I'm going to do is just grab an image, and I'm just going to left click and just drag and drop that here into Substance Alchemist. And you'll see that we have our material creation template. This is also new to Alchemist. And for the image to material, we have some options. You'll notice that we have this AI powered, and then we also have, the previous version, which is what we call bitmap to material. Now, with AI powered, what I want to emphasize as it is today, and Rosalie will be giving us more information on that, is it's been trained to work with outdoor ground type texture environments. So think of things like, rocks and pebbles, dirt grounds, forest ground, bark, tree branches, things like that. And so with this selected here, I'm going to click OK. And you can see here in my layer stack that the image to material AI powered is calculating. And here is the result that I get here in my 3D view. So it's pretty quick to work. And if we take a look in the 2D view, I can see my base color. Now, what I want to do just to showcase is come over here to my scan one input. And this is going to show the actual default image that I used. And you can see that this particular image has some very harsh directional lighting. And if we take a look at what the new filter system has done, is it's completely removed these hard surface, these hard edge shadows. So we get a really great delighting type effect here. Now, if we take a look, we've also automatically produced our normal. If I come over to my image material tab, I can play around with things like the normal details. I can increase the intensity and so on. If we take a look at our roughness information, we have just a few adjustments here we can make to our overall roughness value and adjustment. Here we can take a look at that height, and we can play around with this height equalizer. You'll notice that the height is exceptionally, is done much better than what we were able to produce with bitmap to material. And again, Rosalie will be able to give us a little bit more information about this. But with this new version, we actually can get a sense of the overall depth, because we can have shapes actually overlapping each other appropriately and so on. And then lastly here, if we take a look, we have our ambient occlusion, and I can, tweak a few things here with that. So like I said, again, the overall goal that the Alchemist team was actually going for in this particular version was, the ability to create a material very quickly, very few parameter tweaks that you have to do, and you have something, ready to go with very high quality results. So with that said, I am going to go ahead and stop sharing my screen, and I am going to turn things over to Rosalie, and she is going to actually give us a deep dive into the tech behind this new image to material AI powered. So Rosalie, thanks again for joining us here today. So why don't you go ahead and start sharing your screen, and then just dive in and take us through your presentation.
Thank you, Wes, for this great introduction and awesome demo. So I am Rosalie Martin. I am working at the 3D&I Research and Labs team, and we are really happy to have this image to material feature that is now released in Substance Alchemist. Today, I would like to provide you a bit of context of the work behind, present the typical use case to help the users understand in which case it's supposed to work well and in which case it's not supposed to work well. And so, yeah, let's start. It's coming, I hope. All right. So basically, the main objective here is to provide a way for the user to take a picture, one single picture at high resolution of a material. So the picture is taken from above with any camera device and with a natural lighting environment. And to get in the end the full-fledged PBR material with all the channels defined. So the albedo map, the normal map, the height map, and the roughness map. We have been focusing on two main tasks here. The first one is what can be called the delighting. It's the fact to remove all the effect of the lighting that can have been captured in the input to get a correct albedo, where we have the intrinsic color of the material. And in particular, if we don't do that, we will have artifacts in the resulting material. This is the case on the left side. Here, the shadows hasn't been removed, and so if the light turns around the material, you always see the same shadow. And it's not realistic at all. So you need to have a correct albedo, and doing that by hand or with a tool is very, very long and tedious. So we wanted to provide an automatic way to do that. Second main part is geometry extraction that is composed of two maps, the height map and the normal map. We have more like low frequency geometry in the height map and more high frequency details in the normal map. And it was, the big objective to produce an accurate and realistic material that is really representing the input. So this is the typical setup. You need somebody with, could be a smartphone or any camera. No specific complicated lighting setup. You just need a sun and a sky. It could be a diffuse sky or sunny weather. It doesn't matter. And it is supposed to work well with outdoor grounds and some vegetation and walls and stuff like that. So this is basically the kind of use case we address with, as was said, pebbles, stones, sand, dust, dirt, bark, stone wall, a bit of vegetation. So this is what we really wanted to address here. And the difficulty with one single input is that what is captured, what you have when you take one single picture is just, pixels, right? And each color of a pixel has been affected by the color of the material itself, by the geometry, because if you have like small bumps on your feature, you will have a part that is maybe highlighted and the other one that is a bit occluded. And if you have also big feature, big stones like here, you will have a shadow that is casted next to it. And our brain is able to do that pretty well, but with standard mathematical approach, there are too many parameters that has affected the color that is captured, and it's really difficult to get a correct albedo and normal without several pictures or without user input saying, for instance, where was the light. So here we wanted to take an approach using machine learning, and in particular deep learning, because it's leveraging the statistical domains that is learned during a training. And before going further, I would like to just present the basics behind deep learning, and I will, summarizing that in one slide is a bit of difficult, but I will stay with the basics concept. So first of all, you need a data set. And in the case of the supervised learning, your data set is made of a pair of inputs and corresponding output, basically the answers that you would like your model to answer. Your dataset has obviously has to be representative of the target domain of your problem. So here I'm just presenting a scenario of a classifier, which is not what we have worked on, but just to present that concept. You also need to have a model. So basically, your model will take one input and will process it with a very complicated function, and it will provide you an output. In the case of a classifier of image, which is not always the case, you have an input image, you have an output that is just a label of a category. And in case of deep learning, the model is a deep convolutional neural network made of a graph of layers, and in particular, you have many convolution layers. And the convolution layers is basically defined by a very small convolution kernel that is like, for instance, a 3x3 window of weights that is sliding all over each image. And you get another version of your input. It's kind of extracting higher level information all across the layers. And what is learned when we say we are training a model is just the weights of each convolution kernels. And there are a lot to learn. And to do so, you also need to define a loss function. So basically, the loss function is the function that will allow you to have an evaluation metric of your model, of one instance of your model, so meaning your model with all the weights at one moment. And so it defines like the distance between the output of the model and the ground truth values that you provided with your dataset. And still with the example with the classifier, here it's a good answer, here it's a bad answer. It was a horse and not a dog. So with all these good and bad answer, you will have your loss value that is evolving. And what you need now is a way to minimize your loss function so that it's converged to zero. And this is what we call an optimizer. Basically, the role of the optimizer is to move your weights in the direction of a minimum where you will minimize your loss function. And
Rosalie.
Yes.
Sorry, I don't mean to interrupt you. But yeah, I see. Like, so when you were talking about your loss function, there's the term called ground truth, and I've heard that quite a bit through scanning. Could you just tell us a little bit about what is that? Like, what is the ground truth?
The
like,
ground
what does that
truth
refer
is
to?
It's the correct answer regarding this particular input. So basically here, all this picture of dogs has been associated with the correct answer, which is dog. And you feed that to your network. You have that in your training data set. And the difficulty after that is having your network able, well, first of all, to learn your training data set, but also to generalize to other samples that you have not provided to him. And this is the most difficult part, in fact.
Okay, thank you, Rosalie.
All right, so now this is a big picture of the process we have put in place for getting the PBR material starting from one high resolution input. So due to the high dimensionality of neural networks, we needed to find a solution to address the high resolution input to get a high resolution material in the end, but we cannot process the high resolution input on one time inside the network. It's too heavy. So we adopt a tiled approach where we split the input into tiles of 512 by 512 pixels. This is the dimension of our network. And we have two different networks. The first one for the delighting, so the albedo recovery, and the second one for the geometry extraction. So I won't detail here the architecture, but this is globally how it is shaped. So it is a UNet, which is an part of the encoder decoder, and basically this is totally it's good to use this kind of network in the case of image translation task, which is what we are doing here. We have an input and we would like to have the translated input at the same resolution, but without the shadows and highlights. So our network is, well, shaped like that. It is outputting RGB 512 by 512, which is supposed to be an albedo, and we are providing it with a ground truth albedo. And our loss function is a pixel-wise distance between these two images. It's almost the same thing for the geometry, and we have decided to infer the normal maps by the network because it contains more local information compared to the height map. And here we have decided to use, because it was also performant, we have used the result of the predicted albedo concatenated to the input. So we have a 6-dimension input here to this second unit that is predicting the normal, and we have the same mechanism of loss function here for the normal. And now I'm going to detail the dataset part because it was a huge part of this topic. And in our case, we need to have pairs of input and outputs, an input being a lit material, and the outputs being the albedo and the corresponding normal maps that we would like. And we are lucky to have the wonderful Substance source database that are providing us with a huge amount of realistic and procedural materials. So this is really perfect in our case because we need to have a huge amount of data for the training. And we have a way to augment the substance graph because this is procedural graph. And so starting from one substance file, we are using the preset parameters, that is just a set of parameters altogether that is one instance of this substance file, and that is proven by the technical artist that has created the substance. So we can rely on that, and we know that these presets are a realistic version of this substance graph. And we adopt a prudent strategy to keep realistic data, but with variation. So we kind of do a Gaussian distribution around these presets to make varying the substance graph and get this realistic data, and with a huge amount of augmentation. We are using Substance Automation Toolkit in our pipeline, so it's fully automatized and scriptable and very easy to use. Now that we have materials, we need to render them with varying lighting conditions to have enough instances of what we would like to address. And for that, we have defined a set of HDR environment maps that are really simple and that are representing natural lighting at different hours of the day. And so this is the same material that is rendered just with varying lights. For the render part, we are also using the power of Substance here. So this is a Substance Designer filter that has been made by Nicholas Riemann, which is a PBR render. And that provides a combination with IBL render, standard image-based lighting rendering. So you provide it your material and an environment map. And in addition to that, it is detecting the hotspot. So we are considering that we have one main light in the environment map, and that's okay in our case because this is an assumption that we have made in the beginning. It is removing the hotspot and creating a downscale version of the environment map, and it is casting shadows from this downsampled version. And it is also casting shadows from the hotspot. So this is how we get realistic enough results in a very efficient and fast way, because it was not that easy, and we have to produce a huge amount of data, and we needed to iterate on our data set. So it was really awesome to have that tools. So yeah, and for the big picture, we are starting with around 350 substance files, and yeah, I didn't detail the last step. That is a very classic data augmentation file, data augmentation in machine learning. So we are extracting crops of our resolution, which is 512 by 512, and we are making rotation and translation to add variation to the data. And so we end with 250,000 pair of data for the training, which is enough. And after our network has been trained with all this data, this is the kind of result we get. So the input here is not a picture, it's still a rendered material at the resolution of the network. And you have on the top row the prediction and on the bottom row the ground truth. So you can see it's not totally perfect, but it is kind of realistic enough so that we can continue the process. Now we have reached this point. We have tiles of albedo and normal, and we need to blend them together to get a high resolution albedo and normal. And for that, so if we start with a 2K input, we will have 16 crops. We are processing them by the network separately, and we are stitching them all together. And we have often we have seams. And we decided to interpolate in the gradient domain to remove the seams. And it's working pretty well for the base color. However, for the normal map, it was not enough for some reason. And in particular, in this case, we have a really big feature here. And at the scale of a tile, we can totally miss the geometry, in fact. And for this tile in particular, it was very ambiguous. And for those who are very used to look at normal maps, we don't have the geometry that is recovered here. It's not correct. So to avoid that and to help the network having the big picture of what has been captured, we decided to have a multi-scale approach here. And so additionally to all this process, we are also in parallel downsampling the whole input into a 512 by 512 new input, but low resolution. We are processing it with the same neural network and getting this new normal that is low resolution normal and that contains the low frequency of the image. And then we are just doing a multi-scale blending between these two versions of the normal extraction. And in particular, this is what is driven by the parameters that has been exposed in Substance Alchemist, which is the normal details. So if you go to 0, you have the blurry but low frequency normal. And if you go to 1, you have only the high resolution normal. It's often, if you have small features in your input, it's often better to go through 1. But if you're in this case, it's good to stay at the middle, I would say. All right, so now we are here, we have an albedo and a normal, and we need to get the other maps of the PBR material. For the height map recovery, we are using the normal to height filter that was already in Substance Alchemist and that provides pretty good results. It's basically doing a normal integration using the divergence field of the normal. Then for the ambient occlusion, we are using Substance Designer filter that is reproducing the horizon-based ambient occlusion algorithm, also working pretty well, and we have exposed the ambient occlusion strengths in Alchemist. And finally, the roughness estimation. This one is a bit of a trick, and I think we will have to provide better results and better way to play with it. It's a combination of the albedo, the normal, and the ambient occlusion, and basically we are considering that the more high detail you have in the curvature of your material, and the more you will be rough. And also the albedo is a bit driving the roughness estimation, considering that whiter value will be less rough, for instance. But here we would like to progress on that part in the future. Still, it brings a bit of realism to your material. And in the case of the outdoors, it's working pretty well in most of the cases, but there are some errors sometimes. All right, now it's time to see some results. So this is a big stone that I've shown before. So this is in Substance Alchemist. On the left part, you have the render, and on the right part, you have the scan. And I have tried to reproduce the same lighting condition so that it really looks like the input. Another example of pebbles. This one could be difficult because you have pebbles with barely color variation, and still they have the same kind of pebble geometry. So that's cool. This stone wall is working pretty well too. Here is stone and dust. All the stones with a bit of vegetation, a bark, grass floor with some leaves, and this forest ground to finish. And here, just to show that it is not fake, this is a map that has been extracted by the network. So the input, normal, and albedo and height map. And that's all what I have.
Rosalie, thank you so much. That was quite amazing technical deep dive. That was really cool. And also we have, I forgot to mention everyone, we have Vincent and Maureen is actually in our chat. And so I think Vincent did ask, just let us know in the chat if deep dives like this are interesting to you guys. We're thrilled to have you on the show today, Rosalie, and thank you for taking time to go through this. I'm assuming that this work only took you like maybe a week, okay, maybe 2 weeks, I guess, to finish all this up and get it wrapped in, right?
1.5.
Yeah, 1.5. Yes, that's what I thought. Rosalie, wow. I mean, yeah, your genius knows no bounds. Thank you so much. That was really cool. Very crazy for someone like myself who I can't even add and subtract without using my fingers. So it's quite awesome. But thank you, Rosalie. So, so with that said, next up, we are going to start taking a look at Daniel's presentation. So Rosalie, you can go ahead and stop sharing your screen.
Sure.
And like I said, next up, we have Daniel. Daniel worked on our Substance Alchemist marketing. So he worked with us on creating this amazing scene and really went through Alchemist. So Daniel, why don't you go ahead and start sharing your screen and let's take a look at your presentation, man. Can't wait to see what you have for us. Okay, Daniel, I can see your screen. Take it away when you're ready. Oh, Daniel, I think you might actually be muted. All right, just bear with us just for a second. Just a little bit of a technical difficulty, no problem at all.
Okay, I think
there we go. Yeah,
cool.
No problem. Yeah.
Oh, all right. Sorry.
It always happens. Oh man, no problem. It always happens when it's live. Hey, I made the mistake just starting off with my thing. So yeah, it's just live. Always happens, man. No worries.
Yeah.
Thank you so much for joining us, Daniel. This is awesome, man. This scene was so incredible. And it was really fun to be able to work with you on this release, man. So yeah, can't wait to see what you have for us.
Thank you, Wes. Thank you all the Alchemist team and the Substance team. Here is my project. It's a capsule of time. So I'll show you some references I came from. So the main idea of this this project was I was confined at home, like most of the people at that time, and I wanted to create a large scale space with a feeling good feeling inside. So my reference came from personal experience. I went in Italy last year, in Tuscany, and because it's an old city, you have a lot of old city. There is a lot of patina on the material, so this was very interesting for me on that part. So that was the main photo I came from. So it was a large-scale space inside and outside. The moods, the furnitures. And because in Italy they like a lot of furnitures, they are well-known furnitures. I wanted to mix old style, modern style, and in between all the style mixed together to get a mixed result of the feeling inside. So here are the images from the entrance. I used a lot of image to material to make the material. Especially on this image, you can see the white stone was made from that. I used Alchemist also to do the tile floor. Same for the walls. This walls too was made from Alchemists. I did 4 type of lighting on this image. And this way I could shoot any space, any place, and with playing with the lights, I could have the light falling down on the material nicely and represent something nice. So as you can see, I did the morning one, I did the evening one, daytime, and there is another one with the nights. This is the rocks you showed earlier, Wes. I use it on the scene, and it works perfectly with the bark, and everything was really nice, really easy to set up. Here is an idea of the space. It's in the space. I detailed everything, every part of the project. Here, I did a lot of images. I went crazy on that because everything was so detailed. I was just a photographer and no more a 3D artist, and it was very interesting to do that.
That's awesome. Daniel, did you also like model the scene, or were you using content from a library? How did that work?
I modeled most of the scene. I used some model from internet, but most of the model was done. I did the pottery. I did all the vegetation. The furniture, I did some. Yeah, most of it was modeled. Just a few assets was taken from libraries. Yeah, and that's it. I worked with also, I didn't tell, but I worked with Baptiste to do the tile floor and many of other material because I needed some tools inside the Substance Alchemist. And with Baptiste, we worked together to create the tools like the tile floor and the cracks, and all this was made in Substance Designer with Baptiste.
Yes. Yes, thanks Daniel for these crazy images. So like Daniel said, it was super interesting to work with him. It was the first time that Daniel used Alchemist. So for the team, the Alchemist team and the Substance team, it was really interesting to identify the key points to improve Substance Alchemist. So Daniel started working on the first beta version of this new release. And it was the occasion to exchange a lot with Daniel and more globally to understand the needs of an Archviz artist. And a good example of this collaboration is the creation of a dedicated filter, so the floor tiles, as Daniel mentioned. So this was something that was missing in Alchemist, and it was really frustrated at the beginning. Yep. So we start discussing and explain needs. So he wanted to manage the number of tiles, the joint widths, and to be able to tilt randomly some tiles. So we gave him a first iteration. He was not. He was still frustrated. So we added like a bevel on the joint and still more possibilities. And at the end, it was perfect. It was working for Daniel, and he made the floor that you can see on the scene. And at the end, the filter is shipped by default in Alchemist. So that's a very good example of what we need. All your feedback from the community, from everyone. So we encourage everyone to share your needs on the different platforms. So like we have user voice, Discord, and our forum. Yeah, don't hesitate in the future to ask. We are listening to your needs, and hopefully, like the floor tiles with Daniel, it will come out in Alchemist. And I think now it's your turn, Daniel, to show it live.
Yeah, all right. Yeah, as Baptiste said, it was a lot of frustration, but working together was really interesting. We could create our own tools, and that was very nice.
Hey, Daniel, for the rendering, what renderer are you using for this project?
For the renderer, I'm using Corona on 3ds Max. And, yeah, that's it.
Cool, cool.
All right, let's step on the material. Here in Alchemist, as Baptiste said, the tile was made with a tile floor, and you can add the cracks and the dirt you want on it. And at the end, it renders something very nice and a lot of patina, as you can see on the cracks, and was very rich material, very natural and used. I worked a lot on this, and also, as you saw in the first picture, I worked on the tomate. So the tomate was made from a single image, and I cut just one tomate tile, and and by duplicating and adding some cracks, some dust, and everything, you can have something really rich with only one tile, and that was really cool. So as you can see from the base image scan was this. I extracted only one tile, one part of this, and then at the end it makes the floor. I also work with the veggies. The lemon tree leaves were done also with image to material, AA based, and the result is really nice. Put it on a sphere. Right. Yeah, the result is really nice, really realistic. And it was very simple, just import an image, cut out on Photoshop, import the cutout, and done. Very simple.
And so, Daniel, with this, Baptiste, I'd like to have you comment here. So this is actually another kind of feature of Alchemist that I don't think we've really discussed a lot. But so, Daniel, you created like the opacity cutout map. I think it was like Photoshop or something.
True.
But
yeah.
But Baptiste, you can just drag and drop that opacity map into Alchemist. Can you explain that?
Yes. So with this new release, we also added automatic texture matching. So if your image match a name, so for example, in this case, the image contains opacity in the names of the image. So we automatically match the image to the opacity channel. So it works with all the channels, and you can drag and drop a set of texture coming from different libraries. Or if you have legacy folders with a lot of texture from a long time ago, you can bring them back and adding some live into it, and you will get a fresh new material.
That's awesome, Baptiste. So like I think I've heard you guys talk about just internally like Substance Alchemist is becoming like just this hub of texturing, and you can bring content from anywhere outside of Alchemist. You can create content in Alchemist and so on. But the whole thing is you're constantly processing all this data and spitting out materials that you need.
Yes, and at the end, it was in the previous version, but we also had the export where you can export any materials made with Alchemist to any game engine or renderers with our export preset tool. So you can come from anywhere, from any material, and you can go to almost all the type of game engine and renderers. So yes, you can see it like
All right. I think I'm done.
Hey, Daniel, I had something else I wanted to bring up as well. So could you go back to, I think, the first material, the tile floor that you showed?
Right. Yeah.
Yeah, I think it was, yeah. And so Baptiste, I think when Daniel was showing this first layer, so here you have this tool tile, and then in the layer stack there you have input 1, 2, and 3. Baptiste, this is actually also part of kind of a newer feature of Alchemist where we have this, I forget how you referred to it as, but it's basically like this composition of the way filters can then kind of combine to act together to produce one like Uber filter. Is that right?
Yes. So basically, sometimes you want to combine several material into a single, following a structure. So in this case, we want a checker tile, so 2 materials. And sometimes, for example, if you have a parquet with 2 types of wood, you can, in Substance Designer, build your own generator and define if you want 1 or two materials to be inputted in this generator. So that's one of the power of Substance Alchemist and the whole Substance ecosystem. So you can build your own tools in Substance Designer, and after use the flexibility and the light layer stack of Alchemist to get quick result and iterate very quickly. So we have a full documentation of a full documentation page of how to create those generators in Substance Designer and use them in Substance Alchemist.
Okay, that's awesome, Baptiste. Yeah, we'll have to make some training videos and things on how that process works.
Yes.
So we'll talk about that later. But yeah, that's really cool. I love seeing how much this is expanding. Also, it'd be really great to see you know, the opacity, like how we can generate that within Alchemist without having to go outside. So maybe we'll see that. Okay, so one question, Daniel, that I see coming up here is just was wondering like how you're applying these materials. So I don't think you actually have your 3ds Max scene up and running.
No, it's not.
But could you just, I guess, walk us through a little bit of like, say, some of these materials, like basically, you know, how did you export them? Did you use basically just maps? You know, what preset did you use? And then can you just maybe jump back to some of your rendered images and just talk about like behind the scenes, how you applied them, a little bit about the scene creation?
Actually, I have a capture of my Max scene. So
cool.
I ended up exporting a JPEG, and after that, adding on the slot, on the proper slot, and then that's it. So from the lemon tree, I think the leaves is somewhere around this one. So I came up with the normal bitmap, little color correct to arrange a little bit the color for me, and the opacity and the normal bump, and that's it. Yeah, drag and drop all the export map onto the material editor, and then relink on the right position.
Awesome. And so from Alchemist, when you were exporting, what template did you use?
In Alchemist, you have in the export current view, you can choose a preset, and you can have Corona render, as Baptiste said. You have different render type, and for me it was Corona because I'm using Corona, and then that's it. You choose
Awesome.
the channel you want, normal, diffuse, and then export, and that's pretty simple. For that part, it was really the easiest way. You could create complex material, export easily, and then drag and drop on Max, and it works like a charm.
Wow, that's awesome. Yeah, well, simple enough.
Yeah,
yeah, great. That's awesome. And so another thing I can also mention too is that like if you were wanting to, you could use the Substance archive file, the SBSAR, because we have an integration within 3ds Max that also works with various renders, Corona being one of them. So you could export the SBSAR, like drag and drop that into the node editor, and just run the renderer template, and boom, it creates the material for you to supply it. Sure. So from there, Daniel, like in your scene, like for the lighting and things, like can you talk a little bit about your lighting setup?
Yeah, the lighting setup was made on Corona. You can choose which type of light you want to see. So then I create my secondary light for the night time, like with the interior light inside. And then I did the sun with an HDRI. And the morning was same HDRI. And the rest of the lighting was done with an HDRI, different HDRI to create the mood. And that's it. So yeah, it's pretty simple. It's pretty simple.
Wow, quite stunning. And so the ratio of materials that you created here with an Alchemist, it was most of them, I think it was, or
yeah, most of them. Yeah. Okay. And if it was not Alchemist, I used Painter a lot. As you can see, the blinders were made on Painter. The sofa was made on Painter as well. this part was all made in Painter. Painter was really helpful as well. So if you mix Alchemist for the large scale material with Painter, you can have like very detailed scene simply.
Yeah, that's a workflow that I really enjoy as well. Like a lot of times I'll use Alchemist to just generate for me really quickly these base materials. In my case, I just export those as SBSAR files and then just take them into Painter and use them directly there.
You could mix all, and yeah, with Substance ecosystem, you can take a source, bring it to Alchemist, do a material mixing to source, then put it back on Painter, adding some detail, and then in Max to finish.
Yeah, I wish we had a direct send to Baptiste from Alchemist to Painter. Like, you could paint your scene, send it straight to yourself. That would be really cool. Yeah. But yeah, it is great to be able to work with them all together like that.
Anyway, I hope you like it. I have nothing more to say about this scene.
Oh, well, thank you so much.
Yeah. Thank you.
Oh yeah. Thank you, Dan. This was really cool, man, and it was actually really fun to work with you on that. We had one of our other internal artists, Casimir. So shout out to Kaz as well. Yeah, he and I got to work with you on putting together some of the marketing images, and it was just it was really cool to see you work, man, and your process behind that. It was quite stunning.
Thank you.
All right, so I think at this time, I'm going to take a look. We pretty much just covered kind of all of the kind of questions that we had out here in the chat. So let's see here. I don't think I see anything else. Yeah, there's one more here. So this one, someone's asking here, I think you mentioned you made the plants yourself as well. Do you have any advice on using Substance programs for nature and plants?
For the plants, I use the graphics to build the plants, and you can tell graphics to put an UV map, and then with Substance, I went outside, took a picture, do the material on image to material, and that was very, very simple. The only complicated part was GrowFX. It's kind of frustrating software.
Oh, okay. I'm not familiar with that software. Is that you say GrowFX? Is that like a Max plugin or is it standalone?
Yeah, it's a Max plugin. You start from a seed, adding branch, adding more branch, and then the leaves and maybe the fruits. And you can interact with the object on the scene as well, as you can see with the jasmine or the ivy.
Oh, awesome. So oh, sorry, Daniel.
Yeah.
It generates the UVs for you, said.
Yeah.
Yeah. Did you take any of these plants like into Painter, or did you just apply like Alchemist materials?
No. I think it's too heavy to go on Painter. But yeah, the bark was done on Alchemist with the same process. I went in my garden, take a photo, back on my computer, and then boom.
Well, awesome. Thank you so much, Daniel. I think that's going to basically kind of close out what we have here for the stream today. And we covered a lot of the Q&A already, just kind of as we went through the presentation. So Daniel, you can go ahead and just kind of stop sharing your screen. And we'll start to just kind of close things out. So while you're doing that, I just want to thank everyone for joining us on the stream today. This was a lot of fun to be able to have everybody here together. We had Daniel, which was, again, like I said, Daniel was so cool and such an honor to work with you and have you supplying this artwork for us. Also, it was really cool to have Baptiste and Rosalie. Thank you so much, guys, for coming. I think it's really cool to be able to have like part of our engineering team and our development team to be on these live streams and be able to interact and talk with our community and so on. And so yeah, just let us know on our channels if you guys like to see more of these kind of technical deep dives. I think for one, it was amazing to get the overall kind of workflow from Rosalie and how these processes work. I will say the Substance team, there's quite a few geniuses. So I would love to get some more of those team members on future streams and have them go through things and just give us these technical deep dives like this. And So that'll be it, everybody. Like I said, thanks again for showing. Thanks a lot, everyone, for joining us today. Stay safe, take care, and we will see you on the next live stream. So just stay tuned to our channels for more information on that. And I forgot to mention at the very beginning, I also want to wish Vincent a happy birthday. Thanks, everyone. We'll see you next time.